When looking at chemical or physical changes, you want to ask yourself two main questions. So question number one, did the chemical formula change? If it did, it's a chemical change. If it didn't, it's a physical change. The other main question is, can the change be reversed? If it can, it's a physical change. If it can't, it's a chemical change. Solubility is how much solute, which is the thing being dissolved, will dissolve in a given quantity of solvent, which is the dissolver, at a specified temperature. Temperature is important because if we either heat up or cool down a solution, it will dissolve either less or more. On the right-hand side over here, I've written down aqueous and solid because this top row of the solubility table means that the compound is going to be aqueous, and the bottom row of the solubility table means that it would be non-aqueous, meaning it would not be soluble and not dissolve in water. Our first example here is sodium sulfide. What we're doing is we're looking for where it matches up on the periodic table. At the top here we have a lot of the negative ions, and because sulfide doesn't fit in there, that means we can't use it as one of the negative ions. However, sodium is a group 1 ion, which you can see on the top. So when you look down the first column, group 1 ions are going to be soluble with most things except for the things in the bottom. And because sulfur is not one of those things, we can say that the first example would be aqueous. Our second example, I'll use red for that, magnesium fluoride. We're looking for fluoride right here. We look down and it says it's soluble with most things except for magnesium 2+ and all of the other things in the bottom column, which means that this one would definitely not dissolve and not be soluble, and therefore we give it a subscript of S. So now in green, I'm going to show you that ClO4 is right here at the top. ClO4 is soluble with most things, and you can see that at the bottom, silver is not listed there, which means it is going to be soluble and it'll have a subscript of aqueous. Now for the fourth one, I'm looking for PO43- in the orangey color. PO43-, I can find it right here. And you can see that if it's paired with ammonia, NH4, that means it is going to be aqueous, so I will give it a subscript of aqueous. And then my last example, in the light blue over here, you can see that hydroxide is only soluble with group 1 ions and ammonia, which means it is going to be non-soluble and given the subscript of solid.